Hey guys, so today we are going to see how to find factorial of a number using recursion. So let me first write what we have to do. So we have to find factorial of a number using recursion. Right, so we have this as first we have to find the base case for finding a factorial. So let me write the base case first. So we know that what factorial is, and factorial is n multiplied by n minus 1 multiplied by n minus 2 multiplied by goes till 1. So this is what we have as factorial. So at base case we can say that if n reaches 0, base case can be that if n is equals to either 0 or 1, we can take both, but let's say we take 0, and we have to return 1. Okay, so this is our base case, and let's say what we have as a relation. So relation can be, let's say for an example I'm taking. So what an example of 5 factorial, what we do is we first multiply 5 with 4, then with 3, then with 2, and then with 1. So this is what we do as an example. So this can be the relation that we are multiplying n with n minus 1, with n minus 2, n minus 3, and so on. So I have to generalize this also. So general relation, right? So now I'm going to generalize this. So if we have n factorial, then we have n multiplied by n minus 1 if n is greater than 0, right? So we can say this, that if n is greater than 0, then we have this. So what actually I did here is, what we do is 5 factorial is equals to 5 multiplied by 4 factorial, right? And then we have 4 factorial equals to 4 multiplied by 3 factorial. Then we have 3 factorial equals to 3 multiplied by 2 factorial. Then we have 2 factorial equals to 2 multiplied by 1. And as soon as we get 1 factorial, we can see that 1 factorial is equals to 1 multiplied by 0. So as soon as we get 0, we can simply return, if n is equals to 0, then we can return 1, and as we return 1 here, then we get 1 multiplied by 1, which is again returned here at this position, which is again multiplied by 2. Then this 2 factorial is returned here. So as you can see, I've created what the recursive function do here is that first it calls this thing. First we call 5 factorial, and then it calls 4 factorial, then 4 factorial calls 3 factorial, 3 factorial calls 2 factorial, then 2 factorial calls 1 factorial. And then we are getting the equals, or we are getting the values back from each of the factorials in the opposite order. So we get 1 factorial first, then 2, then 3, then 4, and then 5. And as soon as we get 5, we directly return to our main method, and we get the output. So let's code this. Okay, so here I have recursive factorial. So I'll just put the author name. Yes. Okay, now we can start. So public static void main. So we have this. Now I've created the main. So what I'll do is I'll ask the user for an input. So I'm going to import scanner. So java.util.scanner. Yes, so we have scanner. Now let's create a scanner object. we have a scanner object also. Now let's take an input for an n. So sc dot next int. So we have an integer now. Now let's say I have to print, right? So I have to print, I have to ask the user to print, enter a number. So enter number to find factorial. So I've written this. Now the user will enter the number. Now I have to create the function, right? So it's a recursive function. So first it should be static, then it should return an int. That's quite self-explanatory. And let's put factorial as the method, right? So I have factorial which will take an input of int n, right? So this, then let's check if n is double equals to 0. So as soon as n is equals to 0 we return 1, yes, and then else. So if n is not equals to 0 we can simply return n multiply by factorial we have to call. So factorial of n minus 1. So it's giving me a red line. Okay, I have to return this, return n to factorial of n. So we have this factorial method ready. I just have to print it. So factorial, let me put it in a new line. So factorial is plus factorial of n. Okay, so let's see if this works or not. So I run this file. Now let's see for the output. Okay, so it's asking me for a number. Let's put 5. So 5 factorial is 5 4s are 20, then multiplied by 3 is 60, and 60 multiplied by 2 is 120. So I think the answer should be 120, and we are getting 120. So this is how you create a factorial, how you can find a factorial using recursion. So I have explained this. I'll explain it once again. So it's basic that we know that recursive function calls itself, so that's what we are using. So first I'm creating the base case. So I know as soon as n equals to 0 it should return 1, and if 1 is multiplied with anything it doesn't changes anything, so we can return 1. There's no problem there. After that I have to create a relation. So while creating relation I have to take care that what is 5 factorial. I can take any example. So I know that there is 5 factorial. So 5 factorial, what it is, 5 multiplied by 4 factorial. So I know this is n multiplied by n minus 1. In the next I know 4 factorial is equals to 4 multiplied by 3 factorial. So again it is n minus n into n minus 1, because this time we had n as 4. So we can say that this is n and this is n minus 1. So this is what I generalize in the relation. So as I generalize it, it becomes n factorial equals to n multiplied by n minus 1. Okay, so this should be factorial. So I have to call this in the factorial, and I just have to multiply n. So this is what happens in this recursion. Thank you.